Right, this is Hastings Math Videos. Just finishing up the January 2023 Edexcel Pure Math 3 exam. Question 10 is the last question on the paper, and it looks at modeling and has some differentiation aspects in it. For those who like to just look through the answers, I'm just going to quickly scroll through the question. That's A and B. This is continuing just the working of B. C. Continuing the working. And the end of the working over here, just this little final part. Okay, so that's question 10. All right, so a population of some sort is being studied. They give you this formula. So this is the formula we need. And you're using this formula to model your answers. So the first thing is you want some sort of model where K is a constant to find the number of fruit flies in the population at the beginning of the study. So for all these kind of modeling questions, your F is fruit flies in this case. And if you look here, T days is your time. So obviously the beginning of the study is no days or 0 days. So first thing, just to let T equal to 0, and that will give you the amount of fruit flies in the study. So just at the start of the study, your T is 0. Okay. And then I really think that's a little bit self-explanatory. So I'm not going to do number 10A in an expanded working. Number 10B, they give you some more information. So they give you that there's 200 fruit flies altogether and that it's 15 days later. Okay. So that's, we can write in. So I would immediately write this down or highlight it or something. 200 Fs, this is fruit flies, and the population is 15 days later. And you are required to prove that K equals this. So I write this down when I'm teaching. We want to make it look like this. Okay, this is what K should look like. That's what we're going for. Okay, so start off with your original equation. Original equation is that F equals 350 EKT over 9 plus EKT. I always make funny mistakes, so I check it's the same as this. Good. Okay. That's what we're working with. And make sure you sub in your information into the correct places. So we had our F is 200. And we had our time as 15. So that's there and there. So you just make sure you sub those into the correct places. And it's a little bit of algebra to finish it off. So we have 200 equals to 350 EK. I keep it in a bracket 15 all over 9 plus EK 15. And now we have to rearrange it to look like our RTP. So we need to make this look like that. Okay, so it's just algebra from this section. So if you want to look ahead, get it ready on the right here. I'm going to go through it. Whoopsie. Make it smaller. Let's try do this. Aha. I shall fit it in. Okay. There we go. Right. So we want to make this look like that. So let's stop. I noticed that I was going to use we have a function divided by a function. So you can look at it that way. Just something wrong with this. What is wrong with this? Oh, that explains a lot. Okay. Never mind the function divided by a function thing. I was looking at the next question. Right, so here's the full answer. First step, times both sides by this denominator. So it goes over there. 209 plus EK 15. Okay, equal to 350 EK 15s. All right, times this in. We get 200 times 9, which I already worked out. Oh, I just canceled out. Okay, so what I did is I canceled out, and I noticed that if you divide through, it looks like by 50. I think I divided through by 50 because 50 times 4. So I divided this and this by 50. Okay, so that leaves you with 4 on that side, and it leaves you with 7 on that side, just to explain that step. So now we have 9 plus EK 15. I'm leaving it in this form just for the way that it looks. Okay, so 7E, and this is how you should write it, 15K. Okay, this way that I write it is just for teaching purposes. It's to show that it follows through, but actually you should put that 15 first. So we're still going, we remember that we want to make it look like this, 1/5 ln 12. So we still got quite a way to go. There's, I'm going to times in that 4, and I get 4 times 9 is 36, and then 4E, put us in the correct order, 15K, 7E, 15K. Now we can get all the E's on the one side and all the constants on the other side. So 36 stays in the same place. You minus 4E, 15K on both sides, and you're going to get 3E, 15K is on the right. Okay. Then obviously next thing to do is we can divide through by 3. We divide through by 3 now, we've got a 12, which is a good sign. We wanted a 12 because we obviously want to go. So now there's a few ways to look at this. We're aiming for ln 12, 1/15 ln 12. So we are very, very, very close. One way to look at this is as a log. So a to the power of b equals c. We know that log AC equals B. So if I were to color code this, it's currently in this form. So here's our A, here's our B, and here's our C. So mine is just backwards, but it still works. And then if I were to color code the answer, so then if that's A, then this must be A. And if that's we want B, the B becomes the subject. The whole goal is to make the exponent the subject. Okay, so you want to make the exponent the subject. And finally, we have C over here. Okay, so if we write that out, so that means that we're going to end up with log E C, which is 12, equals to B, which is 15K. So we've made 15K, which was our exponent, into the subject of our new, just to manipulate that. Okay, so log E is ln. So this is sort of the old way of doing it. Another way you could do it, if we look at this in a different way, is this is just the opposite of E is ln. So you could just ln both sides. Okay, so quick way, ln both sides. This ends up being ln 12, just to write that here for you. But if you ln both sides, ln of E is the reverse, so they just cancel out. Ln of E it cancels out, so you end up with ln 12 equal to 15K. And we're nearly there. We want to make it look like, I think we probably just have to divide through by 15 over from memory. It's 1/15 to divide by 15, divide by 15. Yeah, ln 12. So that works. All righty. Number C, Where was it? Number C. They give you some new information. Oopsie. Should really write these numbers down. Number C. So they're saying small t equal to big T. Number of fruit flies is increasing at a rate of 10 per day. Okay, increasing. So 10 per day. So an increasing function, 10 per day. Find possible values of T. So the Q here is increasing function. And the word rate. So if I see the rate, I think rate of change. Rate of change is just another word for dy dx. But in our case, we're not working with dy dx. We are working with df dt. Okay. And the reason the F was the fruit flies or something, and T being the time. And so this is just saying that our rate of change per day is 10 per day. So our rate of change equals to 10. Okay. And they asked for what is big T? What is the time? All right. So we need to find dftt and then equal to 10, and then we have to solve for T. So here we have the U-V thingy that I previously went to by mistake. We get there. Let's take a look. So must fit. There we go. From our previous question, we had, this is our original, it's actually just from the original equation. This is our thing that we need to derive. So we need to derive this, and obviously then we're going to find df dt. So this is a function divided by a function. So immediately, I think the quotient rule. So u-v minus v-u over v squared. This is the quotient rule. This is the order that I teach it in. Okay. I teach it in this order because that negative means that order matters for the quotient rule. Obviously, for the product rule, it doesn't matter, but I teach it this way. So what is our u? Before we get to df dt, we need our u and our v. Those are just things that we're letting, so u just, in this case, is just the top function. So u is the top function. Okay. U dash is just the first derivative of the top function. So 350 EKT. The first derivative of the top function is, it's a E function. So we bring down the A value, which is 350. We leave everything the same. So EKT. And then it's a function inside a function. So you have to times it by the first derivative of this. Okay. Let me change that color. So you have to times it by the first derivative of this, and first derivative of kt is just k. All right, function inside a function times by first derivative of what's inside the function. So we end up with, if we simplify this, we end up with 350 k e k t. Okay, then we have to do v. V in the quotient rule just represents the denominator. So this whole function is v. So v dash, and v dash being first derivative of v. So 9 plus e k t, all in a bracket. I just keep it in a bracket because it helps me remember if I'm using the chain rule or not. It's no need to use the chain rule here. So we just do EKT. EKT is a function of E, so everything stays the same, but you times by the first derivative of the function in the function, which is just K, because the first derivative of KT is K, same thing. So this we'd simplify to KEKT. So we have our U and our V and our U dash and our V dash. The next step is to follow our quotient rule order. So I do u dash v goes that way, v dash u goes that way. Okay. U dash v dash u over v squared. So just to highlight it, write that again, u dash v minus v dash u over v squared. We start with u dash times v. So that is 350 KEKT times by 9 plus EKT. So that was u dash v, and then we minus v dash u. So v dash u is from here to here. Okay. Oops, sorry. That's from here to here. So v dash u, so minus, let me make space. V dash u, so KEKT times by 350 EKTs. And all of this is divided by V squared. So 9 plus EKT squared. Okay. We take it from there. That's the quotient rule applied. And you got to simplify that until you get, we needed, I think, T on its own. So this should be equal to 10. This is the first derivative. The rate or the rate of change needs to be equal to 10. Let me just do this in full. So this times by 9, 350 times by 9 is 3150. So it times it in, and that's KEKT. And then 350 KEKT times by EKT is just 350 KEKT all squared. Okay, so that's just times 10 minus, there's again K, then 350, and again we have EKT times by EKT, so it's just EKT squared. All of this, I'm not going to times it out or anything because it's all just divided by 9 plus EKT squared, all equal to 10. So when I look at this, I see that we have a plus of a whole thing that's exactly the same and a minus of a whole thing that's exactly the same. So if I look here, we have this and this. Oh, where did my K go? Oh, there it is. Okay, it's in the middle. So K and K, exactly the same. 350 and 350, exactly the same. EKT squared and EKT squared, exactly the same. So those effectively just are gone. So what's left over is 315K EKT over 9 plus EKT squared equal to 10. Now I can times over the denominator in order to further simplify. So 3150K EKT and 10 times 9 plus EKT. Oopsie. E to the power of KT squared. You look ahead on the right if you want to. So the 10 cancels out with one of these zeros. We divide through by 10. So effectively, I divided both sides by 10. Then I just have 9 plus EKT squared is equal to 315 KEKT. Now we can times out this bracket. So 315 KEKT, 9 times 9 is 81. 9 times EKT times 2 is 18 EKTs. And then we have EKT squared. Oopsie, that's a plus. All plus. EKT times EKT is EKT squared. Right, where were we? So we bring it all over to one side. I'm going to bring it all to the right. So I'll start with the squared term, EKT squared plus 18 EKT minus 315 K EKT. We were starting on the right, so plus 81 all equals 0. Okay, we're getting there. So this is now in the middle. Just to finish up, to notice that this is a trinomial. How do I notice this is a trinomial? I have a double of the t, which is remember what we're going for is t. We're not going for k. So be careful of that. That's a common error, but you're going for the t. So we have effectively, this is e k squared t squared. So this is double the t in the middle, which is the power of 1. So just to, if that's double, then there's 3 terms, it's a trinomial. I know it has 4 terms at the moment. I'm going to rearrange it by taking out EKT as a common factor, and I'm going to put it on the right, just for more, to emphasize it. So what's left over is 18 minus 315K. That's what's left over if you take out EKT as a common factor. Okay. Plus 81 equals 0. A quick visual of this. If you look at 81, we're not going to easily be able to make 2 brackets and finish this up from here. So 81 is 9 times 9, and this thing in the middle, we don't know what K is, so this is just too much to look at. So I immediately know that I want to use my quadratic formula rather. Oopsie, where's my eraser? What's this thing? Okay. So I want to use my quadratic formula, which you can see here on the right. If you don't remember it. Okay, so this in red. And when we use the quadratic formula, we get 2 options. So negative b is negative, the whole b value is this. So negative 18 minus 31, 315K. Keep it in a bracket because of that negative, plus or minus the square root of b squared. So that whole thing squared, which is 18 minus 315K squared minus 4. Our a value is an invisible 1, and our c value is 81. Okay. And this is all over 2 times 1 because it's the a value. Now, if I look at this, I immediately would start panicking because it can't do anything with it because of those k's. But I remember in the question, one of them, we worked out what k was. We worked out that k was equal to 1 over 15 ln 12. So we know what k is. I sub this in to the formula, and I got the answer that so just remember when you're doing this formula, this is from here. So we had EKT K squared T squared. So it was actually, if I remember correctly, it was EKT squared. So that means that when you do this, if it had been X squared, then you would have been looking for your X's over here, but we're actually going to be looking for EKTs over here. Okay. So this is our EKTs are equal to the stuff we stuck into the quadratic formula. So our EKTs are equal to this thing. So if we sub in the K value, this is our K value. Every time we see K there and there, we put in 1 over 15 ln 12. Then I put that in the calculator, and I got that my EKT can either be, oopsie daisies. Just my EKT from my calculator work is 31.621. That's 3 decimal places. Or my EKT is going to be 2.5615. Okay, so those were my 2 options, but it hasn't asked for EKT. So we have to get rid of this E. And early in this video, I discussed that you can just lin both sides. So you lin this side, you lin this side, lin, lin. And what happens is these two cancel out. Okay. So our KT becomes equal to lin of 31.621, or our KT becomes equal to lin of 2.5615. Quick rearranging. So we just want T on its own. And again, we can sub in for K. So let's first get T on its own. So this over K, this is over K. So this one cancels out, this cancels out. So we have, if we sub in K equals to 1/15 ln 12, you can see it on the right here. You can literally end up with ln 31.621 over 1/15 ln 12. This whole thing can go in the calculator. And the other one was over here. So our T is equal to ln 2.5615 over 1/15 ln 12. Bit of a lot of logs and stuff for the answer on natural logs, but that should get you there. Calculator work, and your final answers will be that T is equal to 20.848, and also T is equal to 5.6779. And just to check back how many decimal points, or if it's 3SF or whatever. So we go back to the first, go back to the question. It asks for 1 decimal place. Okay, so just always check. These are not a 1 decimal place. You want 1 decimal place. So T is 20.8 because this one rounds down, or T is 5.7, or because 6.7 goes to 5.7. And that is the end of this paper. Good.